Hey everybody, I thought I'd give you a little implication table example. In this one what we'll do is we'll start out with the present state and we'll letter things out through H. And then what we'll use for our next state is we'll say that we have x equal to 0 and x equal to 1. That's DC. Then we'll do FH and ED. And then we'll do AECA. Then we'll do FB. And then BHCG. For our output Z, we'll just write out 00101. And then 1101. I think we got that right. So now let's look around for row minimization techniques. I see nothing that stands out. So at our next step, we take as we form the implication chart, implication table. Let's start by numbering from B, lettering from B, and going through H. And then we'll start from A and go to G. Then what we'll do is, I think I'll switch pens so that we can write our transitions a little bit more clearly. And let's do an examination of the outputs first. A must be different from C because of its output being different. In fact, we can see that A is different from C, E, F, and H. B is also different from the same. C must be different from D and G. We can see E must be different from E, F, and H. Let's see now. D is different from E, F, and H. D is different from E, F, and H. E is different from G. F is different from G. G is different from H. And I think that has us covered for all of the outputs. Now let's start doing a row-by-row examination. A to B. From A to B we see D, F, which is already blocked out. So that becomes blocked out. From A to D, we see AD. So that's itself. We see CE. And we might as well check while we're here. That looks empty. Let's look at AG. From A to G, we have BD, and we also have CH. So I got BD and CH. Now CH is also empty. Let's look at BD. From B to D, we have AF and EH. AF has a block on it, so this must be blocked. So now we got to go to CE. CE, it's CE and AD. But AD is CE and CE is AD. These two may be equivalent. And now let's look at CF. C to F, that's EF, BD. Well, BD is blocked, so that means CF must be blocked. Well, what about, oh, we've skipped BG. So from B to G, I have BF and HH, BF. Well, BF is blocked, so this must be blocked. What about CH? Well, from C to H, I have CE, HD, or DH. CE, DH. Now, it turns out CE is AD, DH is, DH is blocked. So that's no good. How about DG? Well, from D to G, I have AB in EH. But AB is blocked, so this must be blocked. And how about from E to F? From E to F, I have CF, but CF is blocked, so this is blocked. How about E to H? Well, from E to H, I have C to C, then I have A to H, but A to H is blocked, so this is blocked. How about F to H? Well, from F to H, I have CF. CF is blocked, therefore this is blocked. So from what we can conclude here, CE is clear. How about AD? That's clear. So C must equal to E, and D must equal to A. And from these sorts of relationships, if D is equal to A, I can cross out D. Anywhere I see D, I can write A. If C is equal to E, I can cross out E. Anywhere I see E, I can write out C. And that certainly gives us a nice reduction. Thank you.